Welcome back, everyone. So, as in the last lecture, actually, we learned about resonance and outer row resonance hybrid structure. We also learned how to compare different resonating structure. In this video, especially, we're going to do some questions around those concepts as we have learned. But remember, resonance is not yet over, as we have to learn aromaticity. Okay, and there's a lot more advanced and nice questions on that concept. And alongside, we are also going to learn about we're also going to learn about resonance energy, and we'll combine more questions about around resonance after that. Okay, so for now, let's do some questions around what we have learned so we can remember it. Okay, so let's get started. So for your first question will be, you have these two structure again. So double bond here, and a double bond here. So tell me which one of these is more stable. I'll give you some time. And yeah, I also need to tell you one thing. Actually, I'm not sure about how to teach you guys. So just give me some ideas. What can I do so you can learn better and we can have more personalized classes? And what concepts do you want to learn through me? Okay. So yeah, give me some ideas and recommendations. What topics you want to learn, because I cannot teach everything. So I'm focusing more on the competitive sides of things. Okay, so tell me which one is more. As you can see, the carbon chain is same. The resonating structures are three. If you compare the number of resonating structure, both have three. And as you can see, all of the electron here are, you know, everything is everything is going on well and nice. Okay, so yeah, tell me which one of these will work. So as you can see, this one has only one directional, right? Conjugation, whereas on the other case, either this will go here and this will go there, or this will go here and this will go there. So this is a cross conjugation. We learned about it, right? So which one will be more stable, A or B? A is more stable than B. Why? Because this one has extended conjugation and the other has cross conjugation, and we talked about it that extended conjugation is more stable than the cross conjugation. I'll give you another example so you don't get confused with this example. Okay, so you have the similar case this side. Okay, 1 2 3, and you have the similar case this side again. Okay, this time, yeah. Okay, as you can see this, tell me which one is more stable, A or B. You have time, you have your time, so just think about in your mind. I think you must have got your thought, as this has extended conjugation, because you might see this double bond but it won't be part of conjugation because it's not in continuity with it, or it can be part of conjugation actually. So the issue here is this, as this is sp3 hybridized, and remember the one which have more resonating structure will be better, and we see extended and normal conjugation when they have similar or same resonating structure. This is sp3, so it will mess this up, whereas this is sp2, so the conjugation will go on. Okay, so this one is one of those examples where B is greater than R, but it's still extended and cross conjugation, but it's still the answer differs. Okay, we'll go on to our question number 3. Questionnaire 3, about, you have the two compounds R, C double bond O and O negative, and CO3 2 negative. This is also called carbonate. If you want me to draw the structure of it, you can draw it like this. You can draw just 2 negative. Okay, anyway, so which one is more stable, tell me. As you can see here, this will go there, this will go there. Okay, here this will go there and this will go there, so both of them are making equivalent resonating structure. As I told you that charges are going on the same metal, so both of them are stable, but when both of them are making equivalent resonating structure, then we need to see which one is making more equivalent resonating structure. As you can see, they just have two resonating structure, equivalent resonating structure I would say, and this has 3 equivalent resonating structure. The more charge dispersed, the less the charge become, and the more stability increase. So here B is stable than A. Hope you understood it. Okay, let's go ahead with our next. Okay, let's go ahead with some more questions. Your next question is, this is question which you'll see a lot of places. Benzene with OH, which is known as phenol. Okay, and this is where I've talked about how to compare the stability of resonating structures. So this is where it will be used. So I'll show you, these are the various resonating structures of phenol. Okay, OH plus, and this will have negative, right? And the third one is this way. These are resonating structures of OH. Okay, phenol. Yeah, I hope you're understanding all of them. So we'll get started after I'm done drawing the question. OH plus. Okay, I can also actually remove this, so for your understanding, if you haven't drawn any figures such as that, so it will look like this. Okay, this is benzene. So 3 atom is in continuous conjugation, so it keeps going on. So what do you think, what will be the order of it? So we'll start by what was our checking way? First, aromaticity, we check whether it's aromatic, non-aromatic, or anti-aromatic. Second, all of them are, so yeah, aromatic. So second, we'll see number of bonds is directly proportional to stability. Okay, then we'll see polar, right? Which non-polar is more stable? Which one of these is non-polar? The third step was polar and non-polar. Till here everything was same, so till here no use. So which one is non-polar? Is this one, and all other are polar. So I'll say first is greater than, then if you see others are polar, so we'll go to the next step, which is nature of charge. So positive charge should be on more electronegative element. All of them have positive charge on less electronegative element, more electronegative element, which is wrong actually. Positive should be on electronegative because they tend to, attract charge more, right? So yeah. So as you can see, all of them are same at that phase. Then we'll see the distance between these two charges. So, oh, I forgot, here it would be negative. So as you can see, the distance between unlike charges should be less, right? And the distance between like charges should be more. As you can see, these two are unlike charges, so the distance should be less. So as you can see, in both of these cases, the distance are same. So B and C are B, and your D is equal. Okay, and lastly, it's your C, because distance between unlike charges are the highest in here. Hope you understood this question. Quite easy, right? This question actually comes, okay? So this is a really important question. Yeah. And remember, after all of this resonance thing, when it's done, we are going to get into mesomeric effect, inductive effect, which a lot of people get confused a lot lately, like why we use, which one is more stable nucleophile, OH minus or OR minus, which one should be better. We're going to talk about all of it. So we'll talk about our example for where you have these compounds such as, this is basically a previous year question, I think, and I'll actually take a level up than to previous year. So if you can just do my notes or what I'm teaching, you can understand all of this. I'm sure you can cope up with any sort of problems, and if you have any recommendation how I can help you out with that, feel free to tell me. I'll do that. CH3 O positive, once again double bond CH, single bond CH negative, and single bond C triple bond N. So it's the same, it's again different resonating structures of the same compound. So CH3 plus, you have to go in the order that I've told you. Okay, this OS plus, then now double bond CH, single bond CH, double bond C, and double bond N negative. So as you can see, number of bond in this one, if you count, firstly what we'll check, if you go to the order, aromatic, check out your notes if you have made one, or check out my last video. The aromatic, there is no aromatic. Then we'll go on to number of bonds. So number of bonds, this one have number of bonds to be 13. This one have number of bonds as 12. This one has number of bonds as 13, and this one has number of bonds as 13. So for sure this will be the last. Okay, we have got it. Now we have to compare A, C, D. Okay, while you're doing MCQs, this can help you a lot too. So if you check out, then what we check next after number of bond is polarity. This one is non-polar, right? So A is the highest A is the most stable, then there comes two more things, and B is the last stable, right? Because of number of bonds. After polarity, what we check? Do you remember, guys? Yeah, check out your notes. After polarity, we check nature of charges. So we check positive charge should be more on positive electronegative. Okay, so we'll see which two we have to compare first. A and B are done, right? We have to compare C and D. So as per this, oxygen have positive charge. So oxygen is electronegative, it should have negative charge, but we have to ignore that fact because these are same in that way, right, for oxygen. So we'll check this negative charge on carbon or nitrogen. Which one should have negative charge? Which one is of these are more electronegative? Nitrogen, right? So it's more stable. I hope you understood how to compare stability between different resonating structure. Did you get this one? Let's go next. Let's go to the fifth example that we have. CH3, NH positive. You just need to follow the order that I've told you before. Okay. CH, stable bond, CH2. Count the bond order. If not aromatic, then go ahead. And if you follow that order, you'll never miss a question that I have told you. Okay. And you will never be wrong at any question. A, B, C. So we have C. I hope you understood how to compare the stability of resonating structure between them, right? Quite easy, isn't it? So yeah, if you check the bond order, it has 15, it has 16, and it has 15 bonds. So which is more stable? B. First, okay, before seeing charge, we have to change bond numbers. So the order which I have told you, all of this, that order should be maintained. Yeah, B is the most stable. Then we have to compare C and A. So you have to see what next. We have to see polarity, both are polar. So what should we see next? We should see which one has more electronegative. As you can see, nitrogen has positive charge, which should not have positive charge, right? And because there carbon has positive charge, which is okay, but here negative charge is also on carbon, so this is common. So positive charge only differs, and positive charge should be at carbon, so it's more stable. Did you get it? Are you understanding the concepts now? I hope you are. Let's go with the sixth question. This is the last question. I'll go on comparing resonating structure, and you can check out your previous year question and you'll find a lot of questions on comparison of resonating structure. Yeah. Two negative and one positive. Okay, so you need to compare these. Bond order all has 4, 4, 4. Okay, number of bonds. Then what we need to see is next we need to see is polar, non-polar. All are polar. So can't compare on the basis of that. Then what we need to see, light charges should be at the maximum distance and unlike charges should be at minimum distance. As you can see, unlike charges is minimum distance. Okay, and as you can see in this two, unlike charges have less distance, but the issue with this is negative charge. If you compare these two, the negative charge is on oxygen, which is more electronegative than carbon, so then nitrogen. So this negative charge makes R for A win, then will be our B, and as you can see both have positive charge, which is obviously something bad. So hope you understood how to compare stability of different resonating structure. Stability. Okay, next on what we are going to learn is about aromaticity. What I'll be teaching you about aromatic, non-aromatic, and anti-aromatic. I won't tell you a lot of. I'll just talk about Hucker rule, and we'll start doing some amazing, like I'll show you the exceptions where Huckle rules don't work, and actually a lot of teachers don't teach that. So yeah, stay connected for that, and we are going to learn about resonance energy, which is another phenomena that we need to look into. I'll see you in the next one. Have fun and have a great day. Bye bye.